My name is Matthew McDermott, and I'll be talking to you about CheXpert++, approximating the CheXpert labeling for speed, differentiability, and probabilistic output. If you've worked with chest radiographs, you may be familiar with CheXpert, a rule-based model that extracts diagnostic labels from free text radiology reports. It has been extremely helpful for the field by enabling the release of several prominent radiograph datasets. However, it's also non-probabilistic, relatively slow, and non-differentiable, all three of which can limit its applicability in certain use cases. We developed CheXpert++, a high-fidelity BERT-based approximation to CheXpert that is probabilistic, fast, and differentiable, opening up these restricted applications for more study. One of those application areas that we focus on in this work is the active learning, and we profile a proof-of-concept active learning system where we use the probabilistic outputs of CheXpert++ to automatically figure out which subset of the label would most benefit from relabeling by human clinicians, and use that to improve overall labeling performance. The CheXpert++ model is trained in a very simple way. We take unlabeled radiology reports, free text radiology reports. We pass those through the CheXpert rule-based model, which extracts diagnostic labels on that free text. And then we train our BERT-based CheXpert++ model simply to match those rule-based labels. So there's no additional labeling required. Now, unsurprisingly, training a BERT model to mimic a rule-based model is a rather trivial task. The disagreement rate between CheXpert++ and CheXpert is less than 0.6% on all diseases, showing that CheXpert++ can be safely used as a drop-in replacement for CheXpert in most applications. We go a little farther than this and actually ask a clinician to examine cases where CheXpert++ and CheXpert do disagree, looking at those sentences and deciding which labeler provided a better answer. And surprisingly here, we find that CheXpert++ is actually preferred over the source CheXpert model almost on average across almost all of our diseases. And this is true despite the fact that CheXpert++ is trained strictly to mimic CheXpert. This demonstrates there's a lot of inductive bias going on in the training of CheXpert++ or the use of a pre-trained clinical BERT model. And that inductive bias actually suggests that we should look at something like active learning to leverage that property to improve performance overall. So how we explore that in this work is we train CheXpert++ in the normal way, then we label a collection of sentences with the model, and we look at those sentences and extract out from that set those sentences for which the model is most uncertain, which at least is least confident about the answer. And then we ask our clinical colleague to actually give a gold standard label for those sentences. Then we augment our training set with those newly labeled sentences, and we retrain the model again with this new information. Now, leveraging a held-out set that was solely labeled by hand to give us a gold standard testing set, we can actually show that even just a single epoch of this kind of active learning induces significant gains over the CheXpert system on almost all disease states, showing that active learning here is really a potential vehicle to offer significant benefit. If you have any questions about our paper, we'd be happy to connect with you during the conference. Please feel free to reach out, and thank you for your time.